Okay, so right now we're talking about integration by partial fractions. We started off with an example that was not a partial fraction situation, but it was just for us to remember how to do long division and break up an integral like this. So when we do long division, we ended up with this expression here, and then divided it out, and then integrated it. Okay, and now we're going to do our first partial fraction situation, which I'm saying is case 1, but I haven't described it yet. I would like to describe it after we do it. Here is the problem, and the first step is to factor the denominator. So if we factor the denominator, we pull out an x, and what are we going to have? 2x squared plus 3x minus 2. And I have 2 people in my audience who are going to check my work and help me. All right. Okay, so let's see. What does this factor down to be? 2x. That's got to be an x minus 2. So that's got to be plus 2, and this is got to be a minus 1. Do you guys agree? Yeah. All right. Now, this what we get for our denominator is what makes this our case 1. Our case 1 is determined after our first step. When we factor our denominator, we see that our factors are each linear factors, and they're all different from each other. So different linear factors. Different linear factors. So now, step 2 would be now to take each one of these and make a fraction out of them. So I'm going to make one fraction where x is in my denominator. Then I'm going to make another fraction where 2x minus 1 is in my denominator. And I'm going to make another fraction where x plus 2 is in my denominator. Okay? And so now, since each one of these are different, what we're going to do is we're going to add an A, a B, and a C, like so. Okay, now what this is that the idea is that there were originally 3 different fractions. And so when you simplify it and put all of the common denominator, or make common denominators and put them together, then what in the end we need to get this to look like this numerator here. So second step is to put them each factor with its own fraction, okay, in the denominator. Now the third step is now to go through the process of putting all our fractions together. And so what does that mean? I needed a common denominator, right? Okay, so what was this one missing? A needed 2x minus 1 and needed an x plus 2. And then B needed an x and an x plus 2. And then C needed an x also and a 2x minus 1. Yeah. So now let's work this out. So let's see, what do I have here? I don't know, 2x squared minus x. So what is this? Plus 3x minus 2. And this is going to be x squared plus 2x. This is going to be 2x squared minus x. Okay, do you guys agree? Okay, so now we have that. So now what's going to happen is we're going to distribute the A to all of this, the B to all of this, and the C to all of that. Yeah? Quite torturous. So I'm going to have 2ax squared plus 3ax minus 2a plus bx squared plus 2bx plus 2cx squared minus cx. Now I am done with my numerator, and this I'm going to say is my numerator. This is all over this common denominator. That would be this common denominator down here, okay, which I don't feel like writing right now. But what happens? This numerator somehow had to simplify to this numerator. So how would we have done that? We would have put all like terms together. So I'm going to use some colors here. All my x squareds, here's an x squared, there's an x squared, there's an x squared. All of my x's, there's an x, there's an x, there's an x. And then all my non-variable terms is this one, and that's it. All right. So now I am going to put all my x squareds together. So if I put all my x squareds together, I can also factor out x squared from each one of these. So I'm going to do that. I'm going to say 2a plus b plus 2c times x squared. That's my pink in this situation. Then let's put all my x's together. I have 3a plus 2b minus c times x. And then the last one that I have is minus 2a. Let me give myself space. So minus 2a, and that's it. Okay, so now this I'm going to consider right here is my step 4. Putting my like terms together. And what this is this, what I have in the parentheses, is the coefficient of x squared in my numerator. So therefore, what is the coefficient of x squared in my numerator? I'm asking you guys. In my numerator. Yeah. So this is supposed to equal 1x squared. What is this coefficient supposed to be? 2. So this is going to be 2x. And what is this expression? There's no coefficient. So what is that supposed to be? -1. Okay, so I'm stealing all of this from my numerator, right? Which now, that is going to help us solve what A, B, and C are. Okay, so we set this up. And then we can go, okay, well then that means then 2A plus B plus 2C, I'm going to set up a system of equations, is equal to 1. And I have 3A plus 2B minus C is equal to 2. And I have negative 2A is equal to -1, which luckily that's going to help us a lot. This is our system. After you are really good at this, you can easily just expand this and then ignore this part right here and go straight to making your system. So now, what does this mean? Let's say step 5 is to solve your system. So easily I can see that A is equal to 1/2. Do you guys agree with that? Okay. A is equal to 1/2. Okay, hold on. All right, if A is equal to 1/2, then you can substitute this 1/2 into here and into here. And what's going to happen is that's going to leave you with B and C in this equation. And B and C in this equation, which now we're going to have 2 equations with 2 variables. And so we can sit there and still continue solving for that system of equations.